Hey everybody, welcome to another episode of the MetaRoy podcast. This is your friend Roy, and every week on this show we are going to make crypto fun and simple by exploring one aspect of the world of crypto. In today's episode, we are going to take a step towards demystifying the complexities of blockchain technology. But before we decode the blockchain through this episode, let us all build something. A community of like-minded crypto enthusiasts, a friendship of sorts. On this podcast, I will always be speaking one-on-one with you. Because I was in your place a few years back too, and I wish I had someone explain it to me back then. If you know somebody who is equally confused as you are, or as I was a few years back when I first learned about crypto, then introduce them to this podcast and bring them together as part of this wonderful community. You know where to find me. I'm available on Apple Podcasts, Spotify, or whichever platform you're listening to me on. There are some really exciting things coming our way soon, so stay tuned to this podcast. Before we start though, let's get a few disclaimers out of the way. I am not a financial advisor and none of the following content is financial advice. So please do your own research and due diligence before making any moves in the crypto space. Now that that's out of the way, let's get started. Okay, now I have observed that when people actually hear the word blockchain, they imagine it to be this impossible thing that probably only rocket scientists or computer science geniuses can understand. They think that the blockchain is something that their brains cannot possibly comprehend, and which is why they stop thinking about everything associated with it as well. But just because something is difficult to understand does not mean we cannot use it, right? For example, does everybody know how electricity is produced? However, don't you flick that light switch and use electricity in your daily lives without giving it a second thought? And doesn't it make your life slightly more better than it would have been without it? Consider that the blockchain is something like that as well, which is already there in your life or is soon going to penetrate every aspect of your life without even you realizing it. The only thing you need to know is that, like electricity or the internet, whether you believe in the crypto narrative or not, blockchain is going to be an essential element of our society. So how do we explain blockchain simply, let's say to a 5-year-old? I think I have a simple story which will make these basics quite clear. When I first read this story, I thought even a 5-year-old could hear this and understand how a blockchain works. So here's how it goes. Imagine that there is this little fellow called Jack who wants, let's say, a Labrador puppy. He's been asking his parents for a Labrador puppy for a long time, but his parents were always finding ways to not get it for him. So one fine day, he figured out a way to get his dream pet. Jack decided that he would send his wish to Santa. He excitedly writes a letter to Santa Claus asking for a Labrador puppy. Since he is too young to go and post this letter himself, he asks his dad to post it to Santa on the way to work. You could almost think of his dad as the middleman between Jack and Santa. However, Jack never imagined that on the way to the post office, his dad would open the letter, read it, and replace the real Labrador puppy on Jack's list with a toy puppy. The letter was posted over to Santa and the elves on the North Pole, and when they received it, they started working on Jack's gift right away. So, on that year on Christmas, Jack received an adorable toy puppy. But next year, Jack decided not to trust his parents but instead to use the blockchain. Jack wrote the exact same letter, but instead of giving it to his mom or dad to deliver, he directly uploaded it to the North Pole blockchain. Now, the North Pole blockchain is made up of a network of computers connected to one another through the internet that all store a copy of everyone's Christmas wish list. The network is being monitored by a lot of people, including Santa himself, all of his elves, and other people, including Jack's parents. Now, every time a letter is received, it gets copied to every individual computer linked to the network, so that everyone has the same copy of the letter which they just got. As the North Pole blockchain is an open network, everyone can see all the letters, but it is impossible to know whom each one belongs to. But for the sake of simplicity, let's assume that somehow Jack's parents came to know about Jack's letter asking for a Labrador puppy. So once again, they changed it, this time for a toy bicycle. But as everyone else in the network had a copy of Jack's real letter, the change was spotted very soon and everybody in the network just rejected the change and it was reverted back to the original copy. So Jack's real letter remained unchanged. And now you can probably guess what Jack received that Christmas. There you go, folks. This was the simplest explanation that I could possibly come up with to explain what a blockchain is. By the way, if you like this story, leave me your comments and thoughts on my website, themetaroy.com, or send me a DM over Twitter @themetaroy, and I would love to hear what you thought about it. Anyway, now that we know how a blockchain network works, why do we need it in the first place? Well, I have given the background behind it in the first episode of this podcast, where I have talked about the history of how the web came into being, and which I strongly urge you to go and check out to understand why blockchain came into the picture. But the short and simple explanation is that it is because with blockchains we finally have a way to code trust into the system itself and distribute it across all the network participants, ensuring that nobody can cheat the system. This way, we can avoid placing our trust in centralized institutions which are prone to bias and corruption. Just out of curiosity, do you know why a blockchain is actually called so? Because it is literally a chain of blocks of data or records that create a digital ledger. Like how we saw in Jack's example, that the North Pole blockchain had a copy of each received letter with each network participant. The blockchain is just a decentralized digital ledger software that keeps records of anything we would like to store on it. Usually, it is something that needs to be stored because it has value for someone, or it has something that someone would care to own. Being decentralized means that there is no central body which maintains the blockchain. Every user connected with their computer to the network, also called as a node, has an up-to-date copy of the ledger. Whenever a new record or block is added to the blockchain, they are made unhackable with cryptography, which is essentially impossibly complicated math that just takes a lot of computing power. Users providing that computing power are called miners. They get economic incentives paid in cryptocurrency, for example Bitcoin, for securing the ledger. The blockchain is immutable, meaning that the records cannot be changed. If someone messes with the ledger, the rest of the network just rejects it. Using cryptographic algorithms, each block is secured and bound to each other. Because blockchain networks have no central authority, the intention of blockchain networks is to create democratized systems where users can verify for themselves if or not a transaction on the chain is legitimate, without the need for a bank, a court, or a government body, for example. The information is open for anyone and everyone to see. No third parties are required, and since it is a shared and immutable ledger, any applications built on the blockchain are transparent, auditable, and permanent. And that is essentially it. That is the blockchain in a nutshell. Now, many of these technologies we now take for granted were quiet revolutions in their time. Just think about how much smartphones have changed the way we live and work. It used to be that when people were out of the office, they were gone because a telephone was tied to a place, not a person. Now we have global nomads building new businesses straight from their phones. And to think, smartphones have actually been around for nearly a decade or so. So let's take a stroll down memory lane to understand where blockchain has evolved from. Believe it or not, the first blockchain-like protocol was proposed by cryptographer David Shom in 1982. Later in the 1990s, two scientists, Stuart Haber and Scott Stornetta, who were working at Bellcore Labs, were trying to solve the problem of authenticating digital documents. In simple words, the question that they were trying to answer was, how could you be sure that the version of the document that you were looking had not been altered from its original version? So, what did they do? They created a cryptographically secured chain of blocks where no one could tamper with the timestamps of documents. They did this using hash functions. Think of hash functions as the fingerprint of a file. In 1992, they upgraded the system to incorporate a data structure called Merkle trees, and this enhanced efficiency and allowed more documents to be collected on a single block of data. And this was the first steps of the system on which the blockchain is built upon today.
Oh yeah.
Now, there were a lot of further developments on this, but another cryptographic activist and computer scientist, Hal Finney, introduced a system called reusable proof of work in 2004 as a prototype for digital cash. It was a significant early step in the history of cryptocurrencies. Now, the problem with digital cash was that it could be copied easily, like any other digital file, which is a problem that physical cash did not have. For example, if you pay for a sandwich with a $10 bill and you gave the printed bill to the maker of the sandwich, you cannot turn around and spend that same $10 elsewhere. However, a transaction using a digital currency like BTC occurs entirely digitally. So what if you pay for that sandwich with BTC and you copied the BTC and used it elsewhere? So this problem was known as the double spend problem, and the solution was being explored by many scientists. But as I mentioned, Hal Finney's reusable proof of work came close to solving it by keeping the ownership of tokens registered on his own trusted server. It was designed to allow users throughout the world to verify its correctness and integrity in real time. However, it was only in 2008 that blockchain started to gain relevance, thanks to the work of one person or a group of persons by the name Satoshi Nakamoto. In October 2008, Satoshi published the white paper titled Bitcoin, a peer-to-peer electronic cash system, which provided details on how the technology was well equipped to enhance digital trust, given that it was running on a decentralized network, which meant no central body would ever be in control of anything. Now, we will explore Bitcoin in much more detail in the next episode, but let's understand that this digital ledger technology that was underpinning Bitcoin has evolved and has resulted in new applications that make up the blockchain. The next progress in blockchain technology was made in 2013 by a developer called Vitalik Buterin, who felt that Bitcoin had not yet reached the full capabilities of blockchain technology. Concerned by Bitcoin's limitations, Buterin started working on what he felt would be a programmable blockchain that could perform various functions in addition to being a decentralized money network. And out of this, Ethereum was born as a new public blockchain in 2013, which had many more functionalities as compared to Bitcoin. And this development had turned out to be a pivotal moment in blockchain's history. Ethereum was different from Bitcoin's blockchain because of a function that allowed people to record other assets and execute contracts by themselves. This new feature called smart contracts expanded Ethereum's functionality from being just a cryptocurrency to being a platform for developing decentralized applications as well. Today, Ethereum's blockchain processes the most number of daily transactions, thanks to its ability to support smart contracts and decentralized applications. Its market cap has also increased significantly in the crypto space. In episode 4, we will go into much more detail about Ethereum and smart contracts. But this was the history of how blockchain came into picture. Now, if you're interested in the potential applications of blockchain in the future, you can actually skip this next part using the timestamps provided in the show notes. But if you're a geek like me, and if you want to understand in a bit more technical detail of how a blockchain actually works, let's dive right in. Now, there could be multiple types of blockchains. There are private blockchains used to store confidential data for an institution. There are federated or consortium blockchains in which data is shared between groups of institutions. But to make it simple, in this episode, we will only talk about public and permissionless blockchains, which are used globally without any restrictions. Let's first divide the word blockchain into two parts, block and chain. A block is a set of transactions that happened over the network. The chain is where the blocks are linked to each other in a way that the next block contains the hash or the address of the previous one. You can imagine this blockchain as a train consisting of multiple carriages connected in a line, where each carriage contains an amount of data. Just like with passengers in a real-life train carriage, blocks can only fit a certain amount of data before they are full. Now each blockchain also contains a timestamp, so it is clear that when the data was recorded and stored, something that is vital for things like transaction or supply chain data, where knowing exactly when a payment or package was processed is important. There is no single master copy of the data on the blockchain. Instead, every user or node who contributes to the network maintains their own copy of the blockchain on their computer, and they constantly check with other nodes to make sure everyone has the same record of data. By having each individual contributor store their own copy means that there is no single point of failure. So it is virtually impossible for malicious agents to tamper with the data stored on blockchain. Even a small change in the previous block can change its hash and break the whole chain, meaning it will create a completely new blockchain altogether. But since the network won't agree on it, the blockchain which has the longest length is always considered as the main blockchain. And that is what makes it difficult to tamper data on a blockchain. So let's say if a hacker wanted to manipulate any transaction on the blockchain, they would have to hack into the devices of at least 51% of the network contributors around the world and change all of the records to show the same thing. Also, every transaction and its respective value are visible to anyone with access to the system. Each node on a blockchain has a unique 30+ character alphanumeric address that identifies it, called a wallet address. Users of the blockchain can choose to remain anonymous or provide proof of their identity to others. And transactions on the blockchain occur between these blockchain addresses. So for verification, we use multiple algorithms. But the two main algorithms in use now are called proof of work and proof of stake. Once a transaction is inputted in the database and the accounts are updated, the records cannot be changed because they are linked to every transaction record that came before them. Various computational algorithms and approaches are deployed to ensure that the recording on the database is permanent, chronologically ordered, and available to others on the network. So using Bitcoin as an example, here's how a transaction is added to a new block. When a Bitcoin user sends a transaction, a message is created with both the sender's and the receiver's public addresses and the amount being transacted. The sender takes this data, adds their private key to the mix, and creates a hash out of it. Basically turns it into a fixed length code. This creates a digital signature to confirm that the person who owns the amount of Bitcoin intends to send it to the receiver. The sender then packages this digital signature with the message and their own public key and broadcasts it to the network. It's kind of like saying, "Hey everyone, I want to send this person Bitcoin." Now, for most of the wallets and other applications, all of this happens under the hood and users do not actually have to deal with the process themselves. So the package transaction joins a waiting room filled with other unconfirmed transactions. And all of these transactions are waiting to be added to the Bitcoin blockchain. This pool is known as mempool. In the case of the Bitcoin network, the miners who have successfully discovered new blocks through proof of work mining then take a batch of these transactions from the mempool. They verify each transaction to make sure each sender actually has the amount of Bitcoin in their wallets that they want to send. They run it through the software to make sure that the package data, which is basically the digital signatures, messages, and public keys, all of these are legitimate. Once they have verified that it is legitimate, they add it to the new block and finally broadcast the proposed new block to the network so that other miners can double check that everything is correct. Now in proof of stake blockchains, this process is quite similar, except instead of mining nodes, which is like a competition towards discovering and verifying transactions, we have users known as stakers or validators, and they have locked away an amount of the cryptocurrency and they carry out the process, and it is more of a lottery than a competition. We will discuss more about consensus algorithms in the next few episodes, but for now let's understand that these nodes can perform a variety of tasks. They can keep a historical records of transaction data, verifying transactions, and adding new blocks to the blockchain. Once a transaction has been approved and added, this information in the blockchain cannot be altered or rewritten. Surprise, surprise, you know how blockchain works. Now, using the blockchain as a base, we are now in the midst of another quiet revolution. We all know, or have at least heard about, how we are able to track money in the form of Bitcoin without the need for a bank, for example. Bitcoin has emerged as a viable alternative for fiat currencies in daily life transactions and has essentially proved to be of immense importance. especially in cases where governments have collapsed, such as in cases of war or economic troubles. You may have also heard of how people are building decentralized applications on the blockchain, or they are using NFTs to keep track of ownership of digital assets such as artwork, music, or other content. We are literally building digital avatars and new metaverse worlds using NFTs and the blockchain. We will explore NFTs and metaverse into more detail in the coming episodes. But have you imagined that these innovations could be great for creating digital identities for people, or proving ownership of real world assets, or even for protecting intellectual property and patents? Imagine a future where your identity lives forever on the blockchain. The minute you're born, a digital record is created, similar to, let's say, a birth certificate. It's like a proof of you being born. Issuing one of these for each child can be an effective way to create a lifelong verifiable identity on the blockchain that is linked to their birth certificate. So let's say the hospital can start recording medical information about you and associate it with the identity that you have from the minute you came into this world. As you enter school life, your academic records, your extracurriculars, any awards that you have won, everything starts getting added to your identity records. It will provide proof of attendance, degrees earned, and other important information which cannot be altered or hacked into. As you go to college, all you need to do is share these academic records with the college administration, and they can use this information to make the decisions regarding admissions. We can create records for courses taken by issuing tokens for each completed course, along with verifying any degrees earned through smart contract verification systems. When you graduate, your employers can access all of your past data about your skills and how you can fit in their requirements. Of course, that also means no more lying on resumes. Everything about your life can be put on the blockchain. Your driving license, your account statements, your credit records, and can be accessed by authorized personnel only when you agree to share the details. And not just that, your medical history and all records of your treatment could also be stored as well. This would ensure that sensitive medical data is accurately stored, accessible anywhere from the world by authorized healthcare providers, across different country borders, and secure from malicious attempts at manipulation. So let's say you go to Maldives and you fall sick. A doctor could potentially just look at your medical records and understand the reasons why you have fallen sick, even if they have no prior knowledge of your medical history. So as you can imagine, this would lead to improved hospital operations by verifying patient identities, recording medical procedures performed without compromising on patient confidentiality. Again, there are a lot of technicalities and compliances in picture to be done before all of this actually comes to fruition. But the point is, all of these are real world use cases. It only goes to show how blockchain tech is not just for financial investments. Rather, it will become part of your daily lives very soon. And it is not just limited to identity records. Any object of value that creates a record to be maintained can possibly be replaced by the blockchain instead of a centralized database. Let's consider another real-world example. Let's take the case of the real estate industry. It is a slow-moving industry because transactions often take a lot of time to be processed. Ask anyone in the real estate industry and they will tell you that proving the ownership of a property to a potential buyer and estimating the value of an asset or property are really big challenges. There is a ton of estimation involved, paperwork to be filed with the regulatory authorities, and it gets difficult to move faster due to bureaucracy. To top it all, documents get lost, misplaced, or sometimes even forged, which makes it even more difficult to prove ownership of your property if it has been possessed by a malicious third party. What if I told you that the ownership of your real estate properties can be proved or tracked and even verified online in just minutes? What if you could sell or transfer the ownership of your real world assets to another party with just a tap of a button? What if, while purchasing a property, you could view the records of all past owners and changes in the property's value since the time it was first sold? And all of this with just a few clicks on your phone, without the need for costly and slow procedures involving government bodies or certifying authorities to prove the authenticity of documents. Does it seem amazing enough? There are many such other cases in the real world where blockchain technologies can make an impact. Let's explore a critical industry, for example, food products. In this industry, we have a massive challenge when it comes to verifying where the products have come from, what are the contents in it, and so on. By using the blockchain, we are giving it an identifier that cannot be tampered with, and we can use blockchain technologies to work in tandem with the supply chain. Even companies will have the ability to track their products from manufacturing through shipping and delivery. So as a customer, you get an insight on what you are spending your money on, where this food product has originated at, what transfer mechanisms has this come through. For example, if you're buying milk, you would know which dairy farm has actually produced this milk, which shipping company has actually shipped this milk, and which retailer has finally sold this milk, and how many days was that milk in the shelf before it actually got sold to you. How about we dive into an even more futuristic example, and one that affects how countries may function. In many democratic countries, voters are required to bring a photo ID and proof of residence with them when they are going to a polling booth to vote. However, many people are actually losing their ability to vote as they do not have their copies of their IDs or any form of documentation that prove where they live or if they are even registered to vote. Even countries which have a centralized digital identity system are still struggling with rigged elections. Now imagine what if we created a digital voter identity system on the blockchain that could not be forged or tampered with. Imagine how it would prove voting rights for people without the need for physical documentation that proves who they are and where they reside in the country. This would also help eliminate cheating and voter fraud, as the digital identity will serve as the official record of those who voted and their votes. So literally, as you can imagine, blockchain technology can create an impact in all of these spheres, and we have barely scratched the surface of possible applications. Now, there have been a lot of innovations aimed towards improving blockchain, some of which we have discussed in the history of blockchain. The major development now is towards building a better consensus mechanism. Right now, in the blockchain world, every computer in the network processes every transaction. And this is slow because the current generation blockchains are secured by something called as proof of work, in which the group with the largest computing power makes the decision. These groups of miners operate vast data centers to provide this security in exchange for cryptocurrency payments. But the new system of proof of stake is aimed at replacing these data centers that allows blockchains to be more decentralized and scalable. We will discuss more on consensus algorithms in the future episode. Another major problem that has been bugging blockchains from scaling is the blockchain trilemma. You know how you can't balance social life, work, and sleep easily? The blockchain trilemma is similar to that. The blockchain trilemma was actually proposed by Vitalik Buterin, where he said that blockchain projects needed to focus on 2 out of 3 choices between decentralization, security, and scalability. Ethereum, for example, chooses security and decentralization over fast transactions. The Solana blockchain, however, achieves fast transactions by compromising on decentralization. A solution to the blockchain trilemma could actually lead to greater adoption of cryptocurrency and widespread usage of blockchain technology across industry. And many projects are working towards finding a solution to tackle the trilemma once and for all. Innovative ideas like sharding, sidechains, and state channels are being used to address the trilemma, but they are still in experimental phases. We will discuss all of these in our upcoming episodes. For now, the closing thought is that blockchain technology represents many years of work by computer scientists, cryptographers, and mathematicians. As the full potential of these breakthroughs hits society, things are sure to get a little weird. Imagine in 5 years, your self-driving cars and drones will use blockchain to pay for services like charging stations and landing pads. International currency transfers will go from taking days to an hour and then a few minutes, with a higher degree of reliability than the current system has been able to manage. But predicting what direction it will all take is hard. Did anybody see social media coming? Who would have predicted that clicking on our friends' faces would replace time spent in front of the TV? People who predict things usually overestimate how fast things will happen and underestimate the long-term impacts. But just to give you an idea of the sense of scale inside the blockchain industry, the changes coming will be the new internet. What we can predict is that as blockchain matures and more people catch on to this new mode of collaboration, It will extend into everything from supply chains to fair elections, quite possibly digital identities for all of us. And given how far the blockchain has come in 10 years or so, perhaps the future could indeed arrive sooner than any of us think. And that's it for today, folks. In the next episode, we will dive in deeper to understand Bitcoin and the history of money. Stay tuned because over the course of this podcast, we will explore blockchain technology in even more detail and understand how it is going to change the way we live in a big way. I hope you enjoyed this episode about decoding the blockchain. I would love to hear your feedback on the episode. Drop me a comment on my website themetaroid.com or on Twitter or Instagram @themetaroid. Bye bye and hope you have a great day.